everybody, Miss Z here, and today we are going to talk about states of matter and heating and cooling curves. So there are three states of matter, and then we're going to talk about the different phase changes that happen between those three states of matter. So in the beakers here, we have gas, liquid, and solid. We can see our solid particles represented by being close together in a uniform shape. Our liquid particles have spread out to take our shape of our container, and they are further apart than our solid particles. And then our gas particles have gone and spread out completely. They have an indefinite shape and take up the entire container. So solids have a definite volume and shape. Right? The size of our cube is its size no matter what. Our liquids have a definite volume. Right? They only fill up this much of our container. However, they have an indefinite shape. That means that they take the shape of what they're in. Finally, we have our gas particles, and we said that they take the shape of our container and they fill every space. So their volume is dependent upon the space that they're in, as is their shape. So they have indefinite volume and shape. Okay. We're going to look specifically at solids. In a solid, the atoms and molecules vibrate in place. We can see them here. They're just vibrating in place. They form a pattern that reduces the energy of the molecules, so at the lowest energy state. And they only vibrate, so they just kind of vibrate back and forth. Liquid molecules collide and move past each other. So they're slipping and sliding past each other. So I like to think of liquids as being slippery. Then we have gases. Our gases here, these atoms and molecules move independently, which means that they kind of spread out and they move all around. They collide with each other frequently and randomly because they're kind of zooming all around, right? So they're flying super fast, right? Zooming all over the place. They collide frequently and randomly. When they collide both with each other and with the sides of the container. So into each other and the sides of the container. These collisions result in pressure, and that's how we get air pressure or gas pressure. And then the distance between the atoms and the molecules is the greatest in the gas. The distance between this molecule and this molecule is the greatest in gases. Liquid is middle and solids is the least. Then we can look at phase changes. The first phase change we're going to look at is melting. So in melting, it's a process of a solid changing to a liquid. The melting point, okay, it's a vocabulary word, is the temperature and pressure at which a solid becomes a liquid. Heat is gained, therefore it's an endothermic process. Eventually, atoms and molecules gain enough potential energy to move further apart and enter the liquid state. So in melting, my molecules are spreading further apart until they break apart from being a solid and become liquid and start to slip and slide past each other. Our next one is freezing. Freezing is the opposite of melting. Here, it's a process of a liquid changing to a solid. Freezing point is the temperature and pressure at which a liquid becomes a solid. Heat is lost, therefore it's an exothermic process, and eventually atoms and molecules lose enough potential energy to move closer together and enter the solid state. So my molecules are slip and sliding apart. They eventually get closer and closer together until they start vibrating in place, and that's when they become a solid. Our next process is evaporation or boiling. This is the process of a liquid changing to a gas. The boiling point is the temperature and pressure at which a liquid becomes a gas. Heat is gained, therefore it's an endothermic process. And eventually atoms and molecules gain enough potential energy to move further apart and enter the gas state. So my liquid molecules are slipping and sliding past. Eventually they can spread far enough apart where they become gas molecules. Then we have condensing. Condensing is the opposite of evaporation. Condensing is the process of a gas changing to a liquid. The condensing point is the temperature and pressure at which a gas becomes a liquid. Heat is lost, therefore it's an exothermic process. And eventually, atoms and molecules lose enough potential energy to move closer together and enter the liquid phase. So they're far apart, and then they move closer together until they become a liquid, and they just slide back and forth. Then we have two processes that you might not have heard of before. The first one is sublimation. Sublimation is the process of a solid changing to a gas. The sublimation point, again, is a specific temperature and pressure at which a solid becomes a gas. Heat is gained, therefore it is endothermic. Eventually, atoms and molecules gain enough potential energy to move further apart to enter the gas state. So you see an example of sublimation in the winter when we have big piles of snow in parking lots and it's super cold out. So the temperature never gets above freezing. And so when it's really cold, we still notice that our snow piles start to diminish. And that's because sublimation is happening. The snow, the ice water, right, frozen water, is going straight into the air, but it's not evaporating, it's subliming. It's going from solid snow to water vapor in the air and going away. Deposition is the opposite of sublimation. So now my process is going from a gas to a solid. The deposition point is the specific temperature and pressure at which a gas becomes a solid. Heat is lost, therefore it's exothermic. Eventually, atoms and molecules lose enough potential energy to move closer together and enter the solid state. An example of deposition is snow. Okay. If we have water vapor in the air and it goes instantly from being water vapor, a gas, to a solid, we get snowflakes. If I have water vapor in the air and it becomes a liquid and then freezes, we get freezing rain and hail. Okay, so deposition is how snow is made and snow is deposited onto the ground. So let's summarize our three states of matter. We have the gas, solid, and liquid. I like to put gas at the top because it has the highest energy. Okay. If I'm going from solid to gas, that's sublimation, and I'm gaining energy. If I'm going from a gas to solid, that's deposition, and I'm losing energy. Solid to liquid, liquid has more energy than solid particles because they're moving around more. So solid to liquid is melting, that's gaining energy, whereas liquid to solid is freezing, that's losing energy. Okay, so solid has the least energy. And then liquid to gas, if I'm going up to a gas, I am evaporating, gaining energy. And if I'm going from a gas to a liquid, I'm going down in energy, that's condensing, so that's exothermic. We can also graph this, and we can graph this by making a heating curve. We will not look at phase diagrams. So we're looking at a heating curve. On our heating curve, we have two axes. We have our y-axis, which is temperature in degrees Celsius. And on our x-axis can either be time or energy applied. Okay. This one is heat added. Heat and energy are equal to each other. We're going to graph our changes in kinetic energy along with our changes in potential energy. And we can see that we start at negative 20 degrees Celsius. At this point, this is a heating curve of water. I'm going to transition my water from negative 20 degrees Celsius to 0. From 0, I'm going to go up to 100 and then up to 120. So at negative 20 degrees Celsius, all the way until I reach 0 degrees Celsius, I have a solid. At 0 degrees Celsius, this is the melting point of my water. We can also call it the freezing point. So melting point, freezing point, same place at 0 degrees Celsius. At 0 degrees Celsius, I have an equilibrium, which means I have equal amounts of my solid and my liquid happening here. So there's both solid ice and liquid water at the same time. Then after everything becomes a liquid, it starts to heat up. And now I'm having a hotter and hotter liquid. During this entire time between 0 degrees Celsius and 100 degrees Celsius, I have liquid water. Then at 100 degrees Celsius, I again start to have a phase change. So I start to boil, and boiling and condensing happen at the same temperature. Okay. So this is again an equilibrium of liquid and gas. Both of them are happening at the same time. From there, once everything becomes a gas, then my gas is just getting heated. And so something we can add to this is our changes in kinetic and potential energy. Anytime I have a change in temperature, I am changing my kinetic energy. So change in temperature here, change in temperature here, change in temperature here, change in kinetic energy. Anytime that I have a constant temperature, that means my molecules are spreading apart, getting closer together. My phase changes is where I have a change in potential energy in both of those places. Okay. So in class, you're going to create a graph. Your graph is going to look similar to this because it's also going to be of water. And you're going to answer some questions about your graph based on the melting point and its boiling point, its starting temperature, ending temperature. You'll have 3 slanted lines, one at solid, liquid, and gas, and 2 straight lines where you have your phase changes. As always, if you have any questions, please let me know. Have a good rest of your day.